Okay, so again, just check out that 1-7 vocab sheet. I color coded as much as I could. All right, who's still looking at it? Okay, give you just another minute. Okay, let's start going over proofwriting. So we have 3 days worth of stuff to do. So we have today, we have tomorrow, and we have, what's up tomorrow? Thursday? Today's Tuesday, right? Okay. So follow along. It should be pretty short, and then you have 2 Google Forms to complete when you're done. One is on deductive reasoning, the other is on just justifying statements. Okay. Okay, so to justify a statement, we need to use prior knowledge of, in this case, definitions. Postulates. Properties. And theorems. So what this is telling you is that in order to proofwrite, nothing is not usable. So that's segment addition postulate, angle addition postulate, definition of perpendicular lines, definition of a midpoint, like you name it, you can use it in proofwriting. Okay. Now here are some additional properties that I actually had you write down in your packets, but you have a nice clean copy now. We have this reflexive property of congruence, where it could be applied to segments or angles. We have the symmetric property of congruence, and what this is telling us is that it just kind of flip-flops, because when you proofwrite, it says, if it says prove, CD is congruent to AB, that's how this needs to end. So you might need to kind of flip-flop it, and that's where the symmetric property comes into play. The transitive property of congruence is basically stating, if you have angle A equal to angle B, and angle B is equal to angle or congruent to angle C, then angle A is congruent to angle C by definition. We kind of talked about that a little bit yesterday, but the same goes for line segments. Now, the reflexive property looks something like this. It could go a couple of different ways. Let's say we have a triangle. I'm going to call it A, B, C. We're going to add kind of a line right here. Here's D and here's E. If I wanted to prove something similar, congruent, whatever, okay, I would state that A would be congruent to itself, because A is actually an angle for this triangle and this triangle. Does that make sense where that's coming from? So they call it the reflexive property because think of it as like looking into a mirror. If you looked into a mirror, you see yourself back, right? Same idea here. You're just using the same piece to help prove something. Again, just a brief example of another thing you could see with reflexive property is, let's just say we have like a parallelogram. And we have this line, and that line segment is called AB. We can state that AB is in fact congruent to itself by the reflexive property because this is shared by both those triangles. Does that make sense? So reflexive property shares in some way. Okay. All right. So a lot of these theorems are on here from your vocab sheet. All right. So your vertical angles theorem, if angles are vertical, then they are congruent. All right angles are congruent. Congruent complements theorem, if angles are complementary to the same angle, then they are congruent. Congruent supplements theorem, if angles are supplementary to the same angle, then they are congruent. If angles are congruent and supplementary, then they are right angles. Okay, so these were all on that front sheet. Questions on that? All right, so let's talk about linear pairs. So this is the now remember, there is a difference between a definition and a theorem. Vertical angles have a definition as to how they are formed, but then there's a theorem that shows that they're congruent. Linear pairs have a definition and a theorem too. All right. So the definition of a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So again, just a little recap here. When we're talking about adjacent angles, we're talking about an overall angle that's split with this ray. So if I called this 1 and this 2, angle 1 and angle 2 would be examples of adjacent angles because they share a ray. Okay. Now this whole non-common sides are opposite rays. If we look, this is the non-common side, that's an opposite ray. And for this angle, that would be the opposite ray as well. Okay. And they would connect kind of right there. So that's the definition of a linear pair. Then we have the linear pairs theorem, which if two angles form a linear pair, so you have to first define that they are a linear pair, then their sum would be 180 degrees. So it says if angle 1 and angle 2 form a linear pair, just like it kind of shows here, then the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. Questions on that? All right, let's look at example A. So we're going to name the property, postulate, or definition that justifies each statement. So if we look right here, all right, we're going to use this figure to answer some of this. So they're telling me, first off, that if ABE, so A to B to E, is a right angle, so they're saying, okay, that's a right angle, then ABE is equal to 90 degrees. What could I use here in order to prove that? What definition, theorem, postulate, property? Let's think about this. So first off, what's the key word here? Or keywords? Go ahead. Right angle. Okay. So we're definitely going to have something involving a right angle in this justification. But what do I have? Do I have a theorem, a property, a definition, or a postulate? Have we heard anything about the right angle postulate? No, right? All right, so have we heard anything about a right angle theorem? No, so we're good there. What about a right angle property? Have we heard anything about a right angle property? Not really, right? So what does it have to be? We heard of a definition of a right angle? Yeah, we have. Okay, I promise you. So in this case, I'm going to write down here the justification is the definition of a right angle. All right, letter B. If angle 2 is congruent to angle 1 and angle 1 is congruent to angle 5, then angle 2 is congruent to angle 5. What's this property? We already talked about this one. Yep. Very good. How about C? Given B is the midpoint of AC, prove AB is congruent to BC. What could we use here in order to prove those two congruent? Keyword here is what? Go ahead. Midpoint. So what is the midpoint thing? Is it a definition? Is it a theorem? Is it a postulate? Is it a property? What do we think? Yeah, go ahead. Definition. So I'm going to write down the definition of midpoint. So letter D, it says the measure of angle 2 plus the measure of ABE. So here's angle 2, here's ABE, equals the measure of DBE. So this entire angle right here. What's that one going to be? So what we're doing is we're adding this one and this one to get the whole thing. What's it going to be? We went over it a little bit yesterday. Said, hey guys, which one is this? Because I knew we were going to see it today. Well, we've got two angles and they're doing what? What's the operation they're doing? Good. They're adding. So what's that? So we have angle. We have addition. Yeah. Absolutely. It's the angle addition postulate. Very good. All right, letter E. If angle 1 is supplementary to angle FBG, then the measure of angle 1 plus the measure of FBG is equal to 180 degrees. All right, so again, if I take a look at this, I have angle 1. So here's angle 1. They're saying it's supplementary to FBG. So here's F, here's B, here's G. So they're saying these two angles are supplementary. So here and pretty much here. So this one and this guy. So what is the rule or whatever that helps us define this to be true? Go ahead. No, not the congruent supplements theorem. That would be if they overlapped. These don't overlap. Yep. Not a linear pair theorem because they're already saying it's not equal to 180 degrees when we add it up. They're telling us it's supplementary. They're not telling us it's a linear pair. Does that make sense? Yeah. So there's something. It's something else. So the key word here is supplementary. What do we think? Definition of supplementary angles. Very good. Letter F you're going to have to write down because for some reason it didn't print. But if angle 2 is complementary to angle 5 and angle 6 is complementary to angle 5, then angle 2 is congruent to angle 6. I'll give you a minute to write that down. All right, anybody still copying down F? All right, so this says if angle 2 is complementary to angle 5 and angle 6 is complementary to angle 5, then angle 2 is congruent to angle 5. What is that one? That's a new one. Go ahead. No, it's talking about complementary. Transitive property just says if they're congruent, then by definition, the other two are congruent. So this one would be if let me erase some things here. We can get a visual. Okay. What a beautiful voice he has. Okay. So angle 2 is complementary to angle 5. So here's angle 2. Here's angle 5. We know those two add up to the 90 degrees or the right angle, okay? But they're also saying 6 is also complementary to angle 5. So these two. So the overlap is 5. And since we have an overlap, what does this have to be? Go ahead. Very good. Congruent complements theorem. All right, what I want you guys to do is I want you to try some A through E on your own, okay? All right, who's still working on these 5? All right, let's go over them. Let's see how we did. All right, so EB. Hold on, it froze. Okay. EB plus BG equals EG. What is that one? Not angle. Very close, though. Are we dealing with angles? What do we have? Segment addition postulate. Very good. So this is the segment addition postulate. Keep in mind, remember, segments are named with 2 letters. Angles are usually 3. Okay? All right. If angle 5 is congruent to angle 6, then BF bisects EBC. What is that one? Go ahead. Very good. Definition of angle bisector. Very good. Do you think it's important to justify like maybe a segment bisector or an angle bisector? Yeah, it is. Okay, because there's technically it works for both. All right. Letter C, if the measure of angle 1 plus the measure of angle 6 equals 90 degrees, then 1 is complementary to 6. What's that one? Go ahead. Very good. Definition of complementary angles. All right, letter D. If the measure of angle 1 plus the measure of angle 5 equals the measure of angle 6 plus the measure of angle 5, then the measure of angle 1 equals the measure of angle 6. What are we thinking? With this one, you should probably think back to some algebra rules for. Let's see. So let's do a little side work over here. I'm going to rewrite measure of angle 1 plus the measure of angle 5 equals the measure of angle 6 plus the measure of angle 5. All right. Ooh, let's make that look like a 5, shall we? What is common between these 2 sides? Go ahead. Measure of angle 5. What happens if I subtract that from each side? Oh my. Here we go. Oh my goodness. Never mind. What happens if I subtract that from each side? What am I going to be left with? Go ahead. Okay. What did I do here? What property did I apply? Okay. You're right. What's the property called, though? When you subtract something equally on both sides? Subtraction. We use subtraction, right? So I'm going to write that down. Subtraction. Property. And we have an equal sign there, right? Of equality. So you guys have applied this stuff. Maybe you don't know or you don't remember what the properties are, and that's okay. But if you are subtracting on each side, or adding on each side, or multiplying on each side, or dividing on each side, it is that operation property of equality. So this is the subtraction property of equality. If I was going to multiply on both sides, it'd be the multiplication property of equality. Division property of equality, and so on. Does that kind of make sense? I think I'll create a Google form for you guys to kind of reiterate that a little bit, just to be safe. Couldn't hurt, right? All right. Let's take a look at letter E. So given line AC is perpendicular to line EG, prove ABG is a right angle. So what are we looking at here? Go ahead. Very good. Definition of perpendicular lines. Questions on this? Anything at all? We're good? Okay. Homework. You have 2 Google Forms. One reviews deductive reasoning. The other is justifying these statements. Take your time on the justifying statements. If you need to Google something, Google it. Okay? Those of you watching at home, have a great day.